Welcome to the Alpha Training and Consulting's online training program. Today we're going to go over basic probability statistics, and specifically we're going to go over the AND statement. Please keep Alpha Training and Consulting in mind when it comes to preparing for ASQ certification exams. We would love to have you as a student. All right, what we're going to do, back to the topic now, the AND statement. Let's go to the whiteboard and discuss this in greater detail. All right, here we are at the whiteboard. In basic probability statistics, there's two main statements, AND statement and OR statement. So I'm going to go over that real quick, even though today we're going to spend our time on the AND statement. Okay, but there's also an OR statement that we'll go over next week. Okay, so in basic, there's more advanced probability statistics, so I call this basic probability statistics. Okay, of course the AND statement, if you're looking at it from a reliability type perspective, you would have, it'd be a mechanical series circuit. This would be probability A, B, C. This would be valves, and we want to fill this bucket full of water. So to do that, valve A must work, and valve B, and valve C in order to fill up the bucket. What would the OR statement look like? It would look like this. To fill the bucket full of water, valve A, we'll call this one valve B. To fill the bucket full of water, valve A or valve B must work. So this is a mechanical parallel type circuit for the OR statement, and the AND statement is like you see there. So those are the two schematics for the two statements. But today we're just going to go over the AND statement. Now, in each of these statements come with an assumption, okay? And the assumption for the AND statement is independence. Independence. And what do I mean by independence? Well, let's go back to this schematic here. Filling the bucket again. Okay, and this is valve A, valve B, and valve C. Okay. Independence means, and we're just talking about the valves here, not filling up the bucket, just the valves. And let's say the probability of valve A working at any given point in time is 0.95. We'll just make them all equal to 0.95 probabilities. And independence means this. If valve A works or does not work, it will not impact this probability of valve B. Okay, the valve B still has the same probability of working whether A works or not. This is called independence. But in this case, I'm just looking at the valves. I'm not talking about filling the bucket full of water. I'm just talking about the probability of the valves working. So that's independence. If A works or does not work, it does not change this probability. That is what we call independence. Well, if it's an AND statement and you say, okay, is the assumption fulfilled? In other words, is the AND statement correct or not correct? So on this branch, I'm going to say yes, independence is realized. Okay, then you simply multiply the probabilities together. It's very simple. The math on basic probability statistics is very simple. The hardest part is getting the right formula, okay? But if you say it's an AND statement and it is independent, you say yes, okay, then you just multiply the probabilities together. If you say, is it independent, it's an AND statement, is it independent, and you say, no, it's not independent, then you will divide the probabilities. And this one's a little bit different. It's a probability of A given B has already taken place equals the probability of A and B taking place. That's the AND statement symbol, by the way, upside down U, divided by the probability of B. So let me read that again. If you say AND, is it independent? No, then you're going to divide. What's the formula? It's the probability of A given B has already taken place equals the probability of B, A and B taking place divided by the probability of B taking place. And so again, it's divide. We're going to go back and we're going to do some example problems with the and statement, independence. Yes, it is independent. No, it's not independent. And that should give you a pretty good feel for the and statement. Let's go back to the PowerPoint. All right, here we are back at the PowerPoint, and let's perform an example problem. The probability of car A starting is 0.47. Probability of car B starting is 0.22. Probability of car C starting is 0.42. So obviously they're not very good cars, are they? We will assume that all three cars must start in order to reach our objective. What does that mean? Then car A must start, and car B must start, and car C must start. Car A and car B and car C must start. That's an and statement. Okay, are they independent? If car A starts or does not start, will it impact car B starting? No, it won't. Therefore, these are independent. Therefore, what are we going to do? We're going to multiply these together. So here it is. Once again, what is the probability of success in meeting the objective of all three cars starting? Assume independence between cars. There you go. So we simply multiply 0.47 times 0.22 times 0.42. You do all the math, and it's 0.043, which is 4.3% chance that car A and car B and car C will start. So it's pretty basic, pretty simple. I know a lot of people that listen to my videos are manufacturing, reliability engineers, etc. And this is also like your spec limits. To get a good part, you need the spec limit 1 to be met, and spec limit 2 to be met, and spec limit 3, and spec limit 4. This is how you get your overall probability of success. As you do capability studies, get these numbers of probability of success on all your spec limits, and you multiply them all together, and it gives you the probability of getting a part that doesn't violate any spec limits. And it's called throughput yield. Okay, and that's how you do it. You just multiply the probabilities together. So a very applicable statement to use in reliability engineering and manufacturing. Okay, now we're going to do the one where it's an and statement, the assumption is independence, the assumption is not met. Now we're going to divide. And remember how this problem works. It says the probability of A given B has already taken place equals probability of A and B taking place divided by the probability of B. Now let's read the example problem. If a given part will crack before it breaks and the probability of a crack is 0.35 and the probability of a part breaking is 0.15, then what are the odds of a cracked part breaking? Okay, for a part to break, first of all, it has to crack and then break. So probability of A and B taking place, the crack and the crack and the break. Why do I point B as the crack? Because B is the earlier event. Let me read it again. Probability of A given B has already taken place. B is the earlier event. Okay, so the probability of a part breaking and a part cracking and breaking, and of course we know that to be 0.35. Or I'm sorry, part breaking is 0.15. Sorry about that. So the probability of a part breaking or cracking and breaking is 0.15, and the probability of a part cracking is 0.35. And now we want to know what's the probability the cracked part will break. Well, you take all the parts that are cracked and you sort them out, and now you're saying what's the probability if I use this that it will break. So that's the type of problem. It is an and statement, probability of the part cracking and breaking, but they're not independent. Therefore we use this formula here. And it's very easy, of course. You divide them, divide them together, you get 4.4286. So the probability if I use a cracked part that it will break is 42.86%. And that's how you do the and statement for independence and no independence. Remember also, especially if you're taking an ASQ exam, sometimes they give you more probabilities than you need. You only need 2, they'll give you 3 or 4. Remember, if you'll just remember that B is the earlier event, that will help you get these questions correct. Let me read it again. How do I know it's the early event? Probability of A given B has already taken place. B is the earlier event. And that should help you out on some of those more tricky questions. All right, keep us in mind for all your ASQ certification exam needs. Here are some of my classes, and I have a website for each one so you can learn about the specific classes. Maybe you're interested in the CRE. That's at www.asqcre.com. There's CQEs in here somewhere. Where's it at? There it is. www.asqcque.com, and etc. Find one that's of interest there to you and go check that out. All right, thank you for joining me in this lecture. I hope you learned something new that will enhance your career. Thank you, and have a great day. Goodbye.